A lone planet drifts on the furthest fringes of a galaxy where the sky has long since surrendered its luster. The horizon above this world does not shimmer with the frantic, sapphire radiance of newborn stars or the iridescent violet of glowing nebulae. Instead, the firmament is a stagnant, haunting crimson, a thick veil of rust-coloured light that hangs over the landscape like the smoke of a guttering hearth. The stars that remain are ancient, weary embers, their furnace hearts cooling as they cling to the last vestiges of their nuclear fuel. This is not the vibrant, chaotic universe of our local neighbourhood, but a silent graveyard of the cosmos, a place where the grand engine of creation has finally stalled and the gears of the heavens have seized in a state of permanent, frigid stasis. In the deep reaches of the past, this same expanse of space would have been a theatre of magnificent violence and fertility. Massive clouds of molecular hydrogen, spanning hundreds of light years, would have collapsed under their own weight, igniting the fierce blue torches of stellar titans. These giant suns, burning with the intensity of 1,000,000 of our own stars, once seeded the void with heavy elements, breathing life into the vacuum through the alchemy of their deaths. But that era of brilliance has vanished. The blue light, the signature of cosmic youth and ongoing birth, has been extinguished, leaving behind only the long-lived, dim red dwarfs that will flicker for trillions of years in a universe that has forgotten how to dream. The silence here is absolute, not merely an absence of sound, but an absence of potential, a stillness that signals the end of a galactic epoch. The transition from a living, breathing spiral of light to this red and dead relic is the most profound mystery written in the stars. We inhabit a brief, privileged window of time where the universe is still fertile, where the Milky Way still churns out a handful of new suns every year, and where the sky is still painted with the remnants of stellar nurseries. Yet, across the vast architecture of the cosmic web, many galaxies have already met their end. They have been quenched, their star-forming gas stripped away or heated to temperatures so extreme that gravity can no longer pull it together to form the next generation of life. The question that haunts the modern astronomer is not just how galaxies are born, but how they are murdered. We must look beyond the beautiful spirals we call home and gaze into the cold, still graveyards to understand why some systems flourish for eons while others become celestial executioners, systematically extinguishing the lifeblood of their neighbours and themselves. The stalling of the cosmic engine is not always a slow, natural death by old age. In the crowded corridors of galaxy clusters, where thousands of island universes are bound together by the invisible grip of dark matter, the process is often swift and brutal. We see galaxies that have been hollowed out, their atmospheres ripped away by the sheer pressure of moving through intergalactic space, leaving them as skeletal remains of their former glory. We see others that have been strangled from within, where the very black holes at their centres, intended to be the anchors of their stability, have instead turned into cosmic blowtorches that incinerate the surrounding gas and banish the possibility of future stars. These are the victims of a universe that is increasingly becoming a place of mere being rather than becoming, a transition from the wild fluidity of the early cosmos to a rigid, frozen architecture. To understand this transformation, we must trace the history of light itself, from the moment the first photons escaped the primordial fog 380,000 years after the beginning, to the present day, where half of the light in the universe has already been emitted. We are witnessing the slow cooling of the grand fire. Every red galaxy we observe is a warning, a testament to the fact that the fertility of space is a finite resource. The gas that fuels the stars is the ultimate currency of the cosmos, and in many regions, the bank is already empty. The stars we see in these dying systems are the last of their kind, a final generation that will watch as the light of their neighbours fades into the infrared and then vanishes into the absolute dark. This journey into the heart of galactic death reveals a universe that is far more predatory and precarious than the steady-state models of our ancestors ever suggested. It is a realm where the largest structures are built upon the corpses of the most creative ones, and where the very gravity that holds a galaxy together can become the mechanism of its thermal execution. As we look out from our own vibrant home, we are forced to confront the reality that the Milky Way is not exempt from this fate. We are part of a grand, unfolding narrative that moves inexorably toward the red sequence, a future where the sky will eventually turn that same stagnant crimson and the engine of our own creation will finally fall silent. We begin our investigation not in the light, but in the shadows of these dead systems, seeking the invisible forces that dictate the destiny of every star and every world. We are the witnesses to the flame, the observers who have emerged in the brief interval between the chaos of the beginning and the eternal stillness of the end. By understanding why the galaxies die, we come to appreciate the fragile brilliance of the present moment, where the stars still burn blue and the potential for life still ripples through the dark. The story of the dead galaxies is the story of our own future, a literary masterpiece written in the language of thermodynamics and gravity, telling us that while the fire must eventually go out, the fact that it burned at all is the greatest triumph of the universe. We stand on the edge of the void, looking up at the flickering embers of ancient suns, ready to uncover the secrets of the celestial graveyard. The mountain air at the summit of Mount Wilson is thin and biting, a sharp contrast to the warmth of the valley below. Here, the great dome of the 100-inch Hooker telescope stands as a silent sentinel, a cathedral of iron and glass dedicated to the interrogation of the night. Inside the darkness, a lone figure works, his breath blooming in the chill air as he guides the massive instrument with the precision of a watchmaker. This is the world of Edwin Hubble, a man who is about to shatter the boundaries of the known world. For centuries, the consensus of the learned was that the Milky Way was the sum total of all existence, a single, majestic island of stars surrounded by an infinite, empty void. The fuzzy, spiral patches of light scattered across the constellations were thought to be nothing more than nearby clouds of gas, the swirling remnants of solar systems yet to be born within our own celestial borders. This was a comfortable, manageable universe, a singular home for humanity that felt both vast and complete. But as the glass of the great telescope drinks in the light of the Andromeda Nebula during the cold nights of 1923, a different story begins to emerge. On a glass photographic plate, the indistinct blur of the nebula resolves into a granular tapestry of individual stars. Hubble searches for a specific type of light, the rhythmic pulse of a Cepheid variable, a star whose periodic flickering serves as a cosmic yardstick. When he finds it, he marks the plate with a simple, triumphant letter V for variable. The subsequent calculations reveal a distance so vast that it exceeds the diameter of our entire galaxy many times over. In that moment, the universe doubles, triples, and then expands by factors of billions. The nebula is not a cloud, it is a galaxy, an island universe containing hundreds of billions of suns, existing far beyond the reach of our own. The key has turned in the lock, and the door to the deep cosmos has swung wide, revealing a reality that is as terrifying as it is beautiful. This discovery marks the beginning of the end for the myth of the steady state. For generations, the prevailing scientific belief was that the universe was a permanent fixture, a static and eternal stage where galaxies would spin in their majestic orbits forever, never aging and never fading. It was a vision of a clockwork cosmos, a perpetual motion machine of divine construction where matter might be created spontaneously to fill the gaps, ensuring that the overall appearance of the heavens remained unchanged through all of eternity. In this steady state, there was no room for death, only for the endless, graceful rotation of stars. But the light captured at Mount Wilson tells a more complex and darker tale. By measuring the stretching of that light, the shift toward the red end of the spectrum, Hubble realizes in 1929 that these distant island universes are all racing away from one another. The universe is not a static sculpture, it is a swelling, changing entity. It has a history, a beginning, and, by the cruel logic of physics, a trajectory toward an end. The realization of galactic mortality begins to take root in the scientific mind as the scale of the cosmos becomes clear. If galaxies are not eternal, then they are subject to the same laws of birth, growth, and decay as the living organisms that inhabit them. They are dynamic engines that transform primordial gas into the luminous bodies of stars. But like any engine, they require fuel. The once eternal spirals are revealed to be fragile structures, their beauty dependent on a finite supply of hydrogen. The telescope, once seen as a tool of quiet contemplation, has become a weapon of existential revelation. It shows us that the cosmos is a place of grand transitions, where the vibrant blue of youth must eventually give way to the somber red of old age. The islands of stars are not immortal gods. They are flickering candles in a rising wind, each one destined to eventually burn itself out as the fuel of creation is exhausted. As Hubble and his contemporaries peered deeper into the void, the awe of discovery was tempered by a growing sense of the dangerous scale of the universe. The vast distances between these island universes suggested a loneliness that was hard to fathom. The sheer number of galaxies, each a potential graveyard in the making, painted a picture of a cosmos that was not a steady, welcoming home, but a theatre of immense and often violent change. The light reaching the mountaintop was a ghost of the past, carrying news of events that had occurred millions of years ago, reminding the observers that they were looking at a universe in flux. The deceptive peace of the night sky was replaced by the understanding of a restless, expanding void where the very fabric of space was stretching, carrying the galaxies toward an inevitable isolation. This shift in understanding transformed the study of the heavens from a simple map-making exercise into a forensic investigation of cosmic life and death. The discovery that the fuzzy patches were distant galaxies meant that every point of light was a laboratory of physics on a scale that defied human experience. Scientists began to ask what governed the lifespan of these massive systems. Why did some continue to churn out stars with exuberant energy, while others seemed to have fallen into a state of quiet, crimson decay? The myth of the eternal, unchanging galaxy was shattered, replaced by the reality of a universe that was aging. The realization was profound. We are living in a universe that is moving from a state of high energy and potential toward a state of entropy and stillness. The Great Telescope at Mount Wilson had not just found more stars, it had found the passage of time on a galactic scale, and with it, the first hints of the celestial executioners that would eventually bring the era of star formation to a close. The island universes were no longer just beautiful ornaments in the sky. They were the protagonists in an epic drama of survival and extinction. And for the first time, humanity was beginning to read the script. The script of the universe remained largely unread until the dawn of the 21st century, when a new kind of eye was turned toward the heavens. This was the Sloan Digital Sky Survey, an ambitious undertaking that sought to map the architecture of the cosmos with a precision never before attempted. It functioned as a grand cosmic census, a systematic accounting of millions of galaxies across the vast northern sky. Using a 2.5-meter wide-angle telescope located at Apache Point Observatory, this survey did not merely take pictures. It captured the light and dissected it into its component colors, creating a library of hundreds of thousands of galactic spectra. Each spectrum was a fingerprint, revealing the temperature, chemical composition, and age of the stars within these distant systems. When the data began to pour in, a terrifying divide emerged in the distribution of these island universes. When the results were plotted on a graph comparing the color of a galaxy to its total luminosity, the pattern that surfaced was stark and unforgiving. On one side lay the blue cloud, a vibrant and chaotic population of galaxies. These are the living systems, characterized by the intense, sapphire light of massive, short-lived stars. They are predominantly spirals, rich in cold hydrogen gas, the raw material of creation. In the blue cloud, the fires of stellar birth burn with unbridled ferocity, and the potential for new worlds is limitless. This is the realm of the young and the fertile, a place where the cosmic engine is still humming with the energy of the early universe. On the opposite side of the divide sat the red sequence. This was a dense, orderly graveyard of galaxies that had long since ceased to produce new stars. They are the ellipticals, smooth and featureless, glowing with the somber, amber light of ancient suns that have survived for billions of years. In these systems, the gas is gone, and the interstellar medium is a barren desert. There are no nurseries, no glowing nebulae, and no hope for the next generation of suns. Between these two distinct groups lay a sparsely populated region known as the Green Valley, a transitional zone where galaxies are caught in the act of dying. The Green Valley is a place of ghosts, inhabited by galaxies that are rapidly losing their color and their vitality. The census revealed a disturbing trend that shook the foundations of galactic evolution theory. The transition from the blue cloud to the red sequence was often too fast to be explained by the natural aging of stars. In the standard peaceful life cycle of a galaxy, star formation should slowly wind down over tens of billions of years as the gas is gradually consumed. However, the data showed that many galaxies were being forcibly moved into the red sequence. Their star-forming engines were being shut down prematurely, often on timescales of only a few 100 million years, a mere blink of an eye in cosmic terms. They were not simply fading away from the exhaustion of their fuel, they were being murdered. Scientists began to look for the invisible hands at work in this celestial crime scene. They found galaxies that still possessed the structural integrity of a spiral, with elegant arms and a rotating disk, yet they lacked any trace of the cold gas needed to sustain life. These passive spirals are the most haunting victims of the cosmos, systems that look healthy from a distance but are hollowed out inside. The signs of strangulation became apparent as researchers looked at the environment surrounding these dying systems. In some cases, the external supply of fresh hydrogen from the cosmic web, the umbilical cord of the galaxy, was being severed. Without this constant influx of new material, a galaxy quickly burns through its remaining reserves and falls into a state of permanent stasis. This census transformed our view of the night sky into a forensic map of a graveyard. The red sequence is not just a collection of old galaxies. It is a repository of victims, a testament to the fact that the universe is far more hostile to the process of creation than we once believed. The blue cloud is a fragile oasis, and the forces that drive galaxies into the red sequence are ubiquitous and relentless. The data from the Sloan Digital Sky Survey proved that the universe is undergoing a massive phase of quenching. The number of dead galaxies has increased dramatically over the last several billion years, suggesting that the era of star formation is reaching a peak and will soon begin a long, slow decline. The philosophical weight of this discovery is immense. We are witnessing the transition from a universe of becoming to a universe of mere being. The Green Valley represents a point of no return, a threshold where the creative potential of a galaxy is permanently erased. Once a galaxy enters the red sequence, there is almost no known mechanism that can bring it back to life. It is a one-way trip into the dark. The realization that galactic death is an active, often violent process shifted the focus of cosmology from the study of birth to the investigation of extinction. It was no longer enough to know where the galaxies were. We had to know what was killing them. The census of the sky forced us to confront the reality that the engine of the universe is being systematically dismantled, one galaxy at a time, by forces that are as efficient as they are invisible. These celestial executioners were now the primary suspects in the greatest mystery of the cosmos, and the search for their identity would lead us to the darkest places in the universe. Deep within the central bulge of a spiral galaxy, where the density of stars reaches a fever pitch and the gravitational tides are strong enough to shred entire solar systems, lies the primary suspect in this cosmic mystery. This is the supermassive black hole, a gravitational sinkhole of such profound magnitude that it contains the mass of millions or even billions of suns compressed into a region of space no larger than our own planetary neighborhood. For eons, this entity may sit in a state of deceptive dormancy, a dark heart beating slowly as it occasionally consumes a stray star or a wandering cloud of gas. But when a significant influx of material, the very hydrogen that would otherwise form new stars, begins to spiral toward this abyss, the sleeping giant awakens with a ferocity that can reshape the destiny of an entire galaxy. The process of destruction begins not with the black hole itself, but with the material falling toward it. As vast quantities of gas are drawn into the gravitational well, they do not fall directly into the void. Instead, the laws of angular momentum force the material into a flattened, rapidly spinning structure known as an accretion disk. Here, the physics of the extreme take hold. The gas in the inner rings of the disk orbits at a significant fraction of the speed of light, rubbing against the slower-moving outer layers with immense viscosity. This celestial friction generates heat on a scale that defies terrestrial comparison, raising the temperature of the disk to millions and even billions of degrees. The result is the transformation of matter into pure, radiant energy with an efficiency that far exceeds the nuclear fusion occurring in the hearts of stars. This glowing disk becomes a quasar, an active galactic nucleus that acts as a cosmic blowtorch. The energy released by this relatively small region of space can outshine the combined light of all the hundreds of billions of stars in the host galaxy by a factor of 1,000. It is a beacon of such terrifying intensity that it can be seen from the opposite side of the observable universe, a lighthouse of the deep void. However, for the galaxy that hosts it, this light is a death sentence. The radiation pressure from the quasar is so immense that it acts as a physical force, pushing against the very clouds of cold gas that the galaxy needs to sustain its fertility. The black hole, in its frantic feeding, creates a feedback loop that begins to dismantle the life support system of its host. The energy does not merely radiate outward as light, it is also channeled into colossal jets of plasma that erupt from the poles of the black hole. These jets, accelerated by powerful magnetic fields to nearly the speed of light, pierce through the galactic disk and extend for hundreds of thousands of light-years into the intergalactic medium. As they plow through the surrounding gas, they create massive shock waves, heating the interstellar medium to temperatures so high that the gas can no longer collapse under gravity. To form a star, gas must be cold and dense, a state of quiet agitation where gravity can overcome the internal pressure of the molecules. By injecting such a staggering amount of heat into the environment, the supermassive black hole effectively boils the galactic nursery. This is the mechanism of active galactic nucleus feedback, a process where the growth of the central demon directly prevents the growth of the galaxy itself. The black hole is a self-regulating governor of cosmic proportions. As it grows larger, it becomes more powerful, and its ability to heat and expel gas increases. Eventually, it clears its entire neighborhood of the fuel it needs to feed, and in doing so, it also clears the galaxy of the fuel needed to create stars. The nursery is left empty, the cradles evaporated by the sheer heat of the central torch. The galaxy is effectively strangled from the inside out, its creative potential sacrificed to the insatiable appetite of the void at its core. The tragedy of this process lies in its terrifying efficiency. A black hole can convert nearly 10% of the rest mass of the material it consumes into energy, whereas a star like our Sun converts less than 1% of its mass into energy over its entire 10 billion year lifetime. This means that even a relatively small amount of gas falling into the central abyss can release enough energy to disrupt the gas reservoirs of an entire island universe. The black hole does not need to eat the whole galaxy to kill it. It only needs to stir the pot with enough violence to ensure that the gas can never again settle into the cold, dark clouds necessary for birth. As the quasar eventually runs out of fuel and goes dark, it leaves behind a hollowed-out shell. The spiral arms may still be visible, and the stars already in existence will continue to shine for billions of years, but the future has been foreclosed. The black hole returns to its slumber, now surrounded by a hot, diffuse halo of gas that is too energetic to ever form a new sun. The galaxy has been moved from the blue cloud of the living to the red sequence of the dead, its soul extinguished by the very entity that sits at its heart. This internal strangulation is the first of many ways a galaxy can meet its end, proving that even in the vastness of space, the most dangerous enemy is often the one that resides within. The dark heart has spoken, and the silence that follows is the silence of a grave that will never again know the light of a newborn star. The mechanism of this celestial strangulation is governed by the relentless logic of the feedback loop, a cycle of cause and effect that ensures the death of the galaxy is as methodical as it is absolute. As the supermassive black hole at the center of the system gorged itself on the surrounding matter, it did not merely consume, it radiated. This radiation is the primary agent of the feedback, a torrent of photons and high-energy particles that flood the interstellar medium. To understand the impact of this energy, one must look to the molecular clouds, those vast, dark reservoirs of cold hydrogen that represent the galaxy's only hope for the future. These clouds are the nurseries of the cosmos, fragile structures that exist only a few degrees above absolute zero. In these frigid depths, the motion of molecules is so sluggish that the subtle pull of gravity can finally win its eons-long battle against internal pressure, collapsing the gas into the dense cores that will eventually ignite as stars. However, when the central engine of the galaxy awakens, this delicate balance is shattered. The intense ultraviolet and X-ray radiation from the active galactic nucleus acts as a scouring wind, penetrating the dark hearts of the molecular clouds. This is not a gentle warming, but a violent injection of kinetic energy. The radiation strips electrons from their atoms and sends them ricocheting through the gas, raising the temperature of the nursery from the depths of the cryogenic void to thousands of degrees. In this heated state, the hydrogen molecules move with such frantic speed that gravity becomes powerless to hold them together. The cradles of the stars do not merely break, they evaporate. The very structures intended to nurture the next generation of suns are dissolved into a hot, diffuse plasma that fills the galactic disk like a toxic fog. This process can be viewed through the lens of a tragic cosmic nursery. In a healthy galaxy, the nursery is a place of quiet, cold potential where the shadows provide the necessary sanctuary for birth. But as the feedback loop takes hold, the heat is turned up to such an extreme that the cradles themselves vanish into thin air. There is no longer any place for the gas to hide, no dark corner where gravity can work its magic. The nursery has been transformed into a furnace, and while the furnace is filled with energy, it is an energy that is hostile to creation. The galaxy is left with plenty of gas, but because that gas is now hot and turbulent, it is as useless for making stars as steam is for building a mountain. This is the essence of quenching, the transition of the lifeblood of the galaxy from a state of fertile cold to a state of sterile heat. The physics of this decline are rooted in the fundamental laws of thermodynamics, first glimpsed by the 19th century physicist Sadi Carnot. In his reflections on the motive power of fire, Carnot realized that any engine, whether a steam-powered piston or a star-forming galaxy, is limited by the temperature difference between its heat source and its heat sink. A galaxy is, in effect, a grand heat engine that converts the gravitational potential energy of falling gas into the useful work of star formation. For this engine to be efficient, it requires a cold reservoir, the molecular clouds, to receive the energy. But when the active galactic nucleus floods the system with heat, it destroys this temperature gradient. The entire galaxy becomes a high-temperature environment, and the efficiency of the star-forming engine drops to zero. According to the second law of thermodynamics, the entropy of the system must increase. The organized, low-entropy state of a cold molecular cloud is replaced by the high-entropy chaos of a hot, ionized gas. The energy released by the black hole is a form of waste, a staggering amount of power that does no useful work in the context of galactic evolution. It is a brilliant, blinding display of cosmic inefficiency. The black hole, in its frantic attempt to process the matter falling into its maw, creates a surge of entropy that washes over the galaxy, wiping away the intricate structures of the spiral arms and the potential for new life. The energy that could have powered the birth of 1 trillion stars is instead dissipated into the void as useless heat, a permanent loss to the creative bank of the universe. This thermal death is the ultimate expression of the black hole's power. It does not need to physically touch the distant gas clouds to destroy them. It only needs to change the thermodynamic state of the entire system. Once the gas has been heated and pushed out of the galactic disk by radiation pressure, it forms a vast, hot halo around the galaxy. This gas is trapped by the galaxy's gravity but is too energetic to ever fall back in and cool down. It remains in a state of permanent agitation, a ghostly reminder of what could have been. The galaxy has become a closed system where no new work can be performed, a state of maximum entropy where the arrows of time still point forward, but the story of creation has reached its final page. As the fires of the active galactic nucleus eventually fade, they leave behind a world that is red and dead. The stars that were born before the Great Quenching will continue to shine, but they are the last of their kind. There will be no more blue giants to light up the spiral arms, no more supernovae to seed the clouds with heavy elements, and no more planetary systems emerging from the dark. The laws of Carnot have been satisfied, and the price of the black hole's brief, brilliant moment of glory is the eternal stillness of the host. The galaxy is now a relic, a testament to the fact that in a universe governed by thermodynamics, the most spectacular displays of energy are often the very things that ensure the eventual end of all activity. The engine has stalled, not for lack of fuel, but because the fuel has been rendered unusable by the very heat of its own heart. Beyond the internal sabotage of the black hole lies a more communal and atmospheric form of execution found within the most crowded neighborhoods of the cosmos. These are the galaxy clusters, vast gravitational pits where thousands of island universes are bound together in a frantic, high-speed dance. In these regions, the space between galaxies is not a true vacuum, but is filled with the intracluster medium, a tenuous, seething soup of plasma heated to tens of millions of degrees. When a vibrant, gas-rich spiral galaxy begins its long fall into the heart of such a cluster, it does not find a peaceful sanctuary. Instead, it encounters the intergalactic equivalent of a terminal hurricane. As the galaxy plunges into the cluster at speeds of several thousand kilometers per second, it experiences a phenomenon known as ram pressure stripping. The hot, diffuse plasma of the cluster acts as a viscous fluid, a celestial wind that exerts a physical force upon the galaxy's own internal gas, while the stars, being dense and compact, cut through this medium like bullets through a fog. The interstellar gas, the very soul of the galaxy, is far more vulnerable. It is a diffuse, spread-out reservoir of hydrogen that is only loosely held by the galaxy's gravity. The invisible pressure of the cluster's plasma begins to push against this gas, resisting its forward motion and slowly prying it away from the galactic disk. The visual result of this process is one of the most haunting sights in the known universe, the jellyfish galaxy. As the spiral is stripped of its lifeblood, long, ethereal tentacles of gas are dragged out behind it, trailing for hundreds of thousands of light years into the void. These streamers are the remnants of the galaxy's creative future, a spectacular wake of blue light and glowing filaments. Within these tentacles, the pressure of the stripping process can briefly trigger the birth of new stars, orphan suns, born in the cold, lonely reaches of intergalactic space, destined to spend their lives far from the warmth of any galactic home. These stars are the last gasps of a dying system, a final, frantic attempt at creation as the galaxy is eviscerated by the wind of the cluster. This is the physics of the kill, a structural dismantling of the spiral arms that proceeds with a cold, mathematical inevitability. The outer edges of the galaxy are the first to feel the blow. The gas in the furthest reaches of the disk, where the gravitational grip of the center is weakest, is swept away with ease. As the galaxy continues its descent into the denser regions of the cluster, the ram pressure intensifies, reaching deeper into the spiral. The once elegant arms, defined by their glowing nurseries and dark dust lanes, are systematically hollowed out. The gas is peeled back like the skin of a fruit, leaving behind only the skeletal framework of the stars. The tragedy of the jellyfish galaxy is that its stars remain largely unaffected by the hurricane. They continue to orbit the galactic center, unaware that their environment has been rendered sterile. To an observer on a planet within such a galaxy, the night sky would slowly change over millions of years. The brilliant nebulae would fade, the dark clouds of dust would disperse, and the vibrant blue light of the spiral arms would give way to a monotonous, aging yellow. The galaxy's ability to replenish its stellar population has been stolen. It has been transformed into a passive spiral, a ghost that still possesses the shape of a living system, but lacks the heartbeat of star formation. This process is a form of cosmic theft on a grand scale. The intracluster medium, by stripping the gas, effectively hoards the material that could have fueled billions of years of galactic life. The stolen hydrogen is added to the vast, hot reservoir of the cluster, where it becomes too energetic to ever settle back into a galaxy. The cluster grows richer in gas, while the individual galaxies within it grow poorer, becoming scorched and barren husks. This is why the centers of great clusters are often referred to as galactic graveyards. They are populated by the red and dead remains of spirals that were once as vibrant as our own Milky Way. The pressure of the void is a silent executioner. It does not require a collision or a violent merger to destroy a galaxy. It only requires motion. The very act of a galaxy moving through its environment becomes the instrument of its demise. This highlights a fundamental truth of the cosmos. Isolation is often a prerequisite for longevity. A galaxy that wanders too close to the great cities of the universe risks losing everything that makes it a living system. The structural dismantling is absolute, and once the gas is gone, there is no mechanism to retrieve it. The tentacles of the jellyfish galaxy eventually dissipate into the intergalactic fog, leaving behind a naked collection of stars that will spend the rest of eternity slowly cooling, their potential for new life forever scattered to the winds of the cluster. In this way, the large-scale structure of the universe acts as a filter, favoring the survival of the isolated, while systematically quenching those that seek the company of their peers. The jellyfish galaxies are a warning, a visible manifestation of the invisible forces that govern the transition from the blue cloud to the red sequence. They remind us that the soul of a galaxy, its gas, is a fragile thing, easily lost to the relentless pressure of a universe that is constantly in motion. As these systems continue their plunge toward the cluster core, they settle into a state of permanent stasis, their stories of creation ended by the very medium that connects the galaxies together. The hurricane of the cluster has passed, and in its wake, only the silence of the red sequence remains. At the absolute heart of these gravitational pits, the silence of the red sequence is not a sign of emptiness, but of a completed conquest. Here dwells the apex predator of the cosmos, the giant elliptical galaxy. These entities are the largest single structures of organized matter in the universe, bloated spheres of amber light that can contain the mass of tens of trillions of suns. They do not possess the elegant, winding arms of a spiral or the chaotic brilliance of a starburst. They are featureless, majestic tombs. Their growth is not fueled by the internal birth of new stars, but by a process of relentless celestial cannibalism, where the giant expands by devouring the vibrant, smaller neighbors that are drawn into its inescapable reach. The feast begins when a smaller spiral galaxy, still shimmering with the sapphire light of its own nurseries, wanders too close to the gravitational well of the central giant. This is a catastrophe unfolding in slow motion, a drama played out over hundreds of millions of years. As the spiral approaches, it feels the first touch of tidal forces, the differential pull of gravity that is stronger on its leading edge than on its trailing side. These unseen hands begin to stretch the spiral, distorting its symmetry and pulling its delicate arms into long, glowing ribbons of stars. The structural integrity that the galaxy maintained for billions of years is effortlessly unraveled. This is the physics of dynamical friction, a subtle but lethal mechanism of the deep void. As the smaller galaxy moves through the outer halo of the giant, its gravity wakes the surrounding stars and dark matter, creating a density of mass behind it that acts as a gravitational drag. This invisible wake pulls back on the intruder, siphoning away its orbital energy and forcing it to spiral inward toward the center of the giant. There is no escape from this descent. The smaller system is caught in a terminal plunge, its fate sealed by the very laws of motion. With every orbit, it is drawn closer to the amber glow of the predator, its identity being systematically erased. The imagery of the merger is one of magnificent ruin. The gas and dust of the spiral, if any remains after its journey through the cluster, are stripped and heated, added to the diffuse, hot atmosphere of the giant. The stars, however, are integrated. They are torn from their original orbits and scattered into the vast, swarming sea of the elliptical galaxy. The beautiful, ordered rotation of the spiral disk is replaced by the random, buzzing motion of 1,000,000,000,000 stellar orphans. The central giant does not change its shape to accommodate the newcomer. It simply grows larger, absorbing the stars of the victim until no trace of the original galaxy remains. Herein lies the paradox of growth that defines the largest structures in the universe. The giant elliptical galaxies are the most massive and imposing objects in the sky, yet they are built entirely upon the corpses of the most creative and fertile systems. To become a giant, a galaxy must cease its own internal production and instead become a scavenger of the work of others. The massive structures we see at the centers of clusters are monuments to the dead, collections of millions of individual histories that have been merged into a single, stagnant whole. Every star in the giant was once part of a smaller, perhaps more vibrant world, but now they are all part of a collective that has no future other than slow, radioactive decay. This process of cannibalism ensures that the center of the cluster remains a place of absolute quenching. Any fresh gas that might have been brought in by the smaller galaxy is quickly shocked and heated by the merger, joining the trillions of degrees of the surrounding plasma. The central giant acts as a thermal anchor, ensuring that the environment remains far too hot for the birth of a single new sun. It is a self-perpetuating cycle of sterility. The more the giant grows, the more powerful its gravitational influence becomes, and the more neighbors it can draw into its sterile embrace. The structural dismantling of the spiral galaxies is a testament to the cruelty of the cosmic hierarchy. The most complex and beautiful forms, the spirals with their intricate dust lanes and glowing star-forming regions, are the most fragile. They are the primary fuel for the growth of the featureless ellipticals. We see a universe where complexity is traded for mass, and where the fertility of the small is sacrificed to the longevity of the great. The giant at the center of the cluster is a survivor, but it is a survivor that has lost the ability to dream. It is a gargantuan relic, a witness to the countless lives it has consumed to reach its current, bloated state. As the eons pass, the cluster core becomes increasingly dominated by these amber-colored titans. The vibrant blue light that once filled the region is replaced by a uniform, aging glow. The celestial cannibalism is a final stage of evolution, a point where the creative energy of the Big Bang has been processed and locked away in the most stable, yet most stagnant, configurations possible. The giant elliptical galaxy stands as a warning of what happens when growth is decoupled from creation. It is the ultimate expression of the red sequence, a place where the history of the universe is written in the integration of billions of individual tragedies, all merging into the silent, eternal stillness of the cosmic graveyard. The feast is nearly over, and the predator is finally full, leaving only the cold, dark expanse of the cluster to watch over the remains. The visible carnage of galactic cannibalism and the shimmering tentacles of the jellyfish galaxies are merely the surface ripples of a much deeper, more shadowed reality. To find the ultimate architect of galactic quenching, the gaze must shift away from the light and toward the invisible scaffolding that holds the cosmos together. This is the realm of dark matter, a substance that does not emit, absorb, or reflect light, yet exerts a gravitational dominance that dictates the birth and death of every structure in the universe. The first glimpse into this dark machinery came in the 1930s, through the keen and often abrasive mind of the eccentric genius Fritz Zwicky. While observing the Coma cluster, Zwicky noticed that the galaxies were moving with such ferocious velocity that the visible mass of their stars and gas was insufficient to keep them bound together. They should have flown apart like sparks from a grindstone. He realized there was a hidden, missing mass, what he termed dunkel materie, providing the invisible glue for the cluster. This dark matter does not merely sit idle. It forms vast, spherical cocoons known as halos, within which the visible galaxies are nested. These halos act as the primary gravitational wells of the universe, drawing in the primordial hydrogen gas from the cosmic web. However, As a galaxy grows, and its dark matter halo reaches a critical threshold of mass, typically around 1 trillion times the mass of our Sun, the very gravity intended to nourish the galaxy becomes the instrument of its thermal execution. This is the phenomenon of the virial shock, a violent transformation of energy that occurs at the boundary where the intergalactic medium meets the galactic atmosphere. As fresh, cold gas falls from the cosmic web into the deep gravitational pit of a massive dark matter halo, it accelerates to incredible speeds, often exceeding hundreds of kilometers per second. When this infalling material strikes the gas already residing within the halo, the kinetic energy of its fall is instantaneously converted into heat. This creates a permanent, standing shock wave that wraps around the galaxy like a suit of incandescent armor. The temperature of the gas behind this shock jumps from a few degrees above absolute zero to millions of degrees. This is the virial temperature, a state of extreme thermal agitation where the atoms are stripped of their electrons and move with such chaotic speed that they can no longer settle or condense. The dark matter halo has effectively become an invisible cage of fire. In a smaller galaxy, the gas can cool down by emitting radiation, losing enough energy to eventually fall into the center and form new stars. But in a galaxy surrounded by a massive halo, the cooling process is too slow to compete with the sheer volume of heat generated by the virial shock. The gas is trapped in a state of permanent suspension, a hot, diffuse plasma that fills the halo but remains forever out of reach of the star-forming disk. The fluid dynamics of the cosmos here act as a one-way valve. The halo continues to pull in material from the outside, but it refuses to let that material cool down enough to be useful. This creates a paradox of abundance. A quenched elliptical galaxy may be surrounded by enough hydrogen to create 1 billion new suns, yet it remains red and dead because that gas is held in a thermal prison. The gravity of the dark matter, which originally provided the seed for the galaxy to grow, now prevents it from ever being reborn. The life-giving flow of the cosmic web is severed not by an absence of material, but by a barrier of energy. The galaxy is effectively strangled by its own weight, its creative potential suffocated by the very forces that hold it together. Fritz Zwicky's dark scaffolding is thus revealed to be a graveyard of potential. The large-scale structure of the universe is a trap, where the most successful accumulations of mass are the ones most likely to suffer a thermal death. The virial shock ensures that once a galaxy reaches a certain size, its era of star formation is over. It becomes a closed system, isolated from the fertile streams of the universe by a wall of million-degree plasma. This is the silent, invisible mechanism of the kill, a process that requires no black hole and no cluster wind, only the relentless, crushing logic of gravity and thermodynamics. The atmosphere of such a galaxy is a seething, invisible ocean of heat. To any light-based instrument, this region appears as a void, yet it is a place of intense physical struggle. The dark matter halo provides the arena, and the virial shock provides the heat, creating a world where the laws of motion have conspired to end the era of creation. The galaxy within is left to age in solitude, its stars growing older and redder, while the massive reservoir of fuel just beyond its borders remains tantalizingly close, but forever inaccessible. This is the true nature of the cosmic cage, a structure built of the most abundant material in the universe, designed by gravity to be the ultimate protector, but destined by physics to be the ultimate executioner. The scaffolding of the universe is not just a support system, it is a series of isolated cells where the light of the future is systematically extinguished by the heat of the present. The grand architecture of the universe is defined by the cosmic web, a vast, interlacing network of dark matter filaments that spans the entirety of the observable void. These filaments are the primordial rivers of the cosmos, carrying streams of cold hydrogen gas from the vastness of intergalactic space into the hearts of growing galaxies. This inflow is the lifeblood of all stellar creation, a constant supply of fresh material that allows a galaxy to remain fertile for billions of years. However, the most common fate for a galaxy in a maturing universe is not a violent collision or a sudden explosion, but a quiet and methodical process of strangulation. This occurs when the connection to the cosmic web is severed and the galaxy is left to survive on its internal reserves alone. The act of strangulation is a quiet, almost invisible crime against the potential of the heavens. It begins when a galaxy is drawn into an environment that is too hostile for the delicate filaments of the web to survive. As the galaxy enters a massive dark matter halo or joins the outskirts of a great cluster, the external pressure and the heat of the surrounding medium act as the shears of the void. The galaxy is like a deep-sea diver, descending into the crushing depths of the ocean, while tethered to the surface by a thin, shimmering line of oxygen. This line is the hydrogen filament, the only source of breath for the star-forming nurseries. When the environmental forces pinch this line shut or sever it entirely, the diver is suddenly and irrevocably alone. The oxygen that remains in its lungs is all it will ever have. What follows is a slow and agonizing consumption of the self. The galaxy does not immediately realize that its supply has been cut off. It continues to churn with the momentum of its youth, its spiral arms still pulling what remains of the internal gas into the dense cores of new stars. For a few 100 million years, the fires burn with a deceptive intensity, but there is no replenishment. Every new star is a withdrawal from a bank account that no longer accepts deposits. The massive blue stars, the short-lived titans that define the beauty and the color of a living galaxy, are the first to flicker and fail. They burn through their fuel with reckless abandon, dying in spectacular supernovae that blow even more of the precious remaining gas out into the void. In its frantic attempt to maintain its identity, the galaxy is inadvertently accelerating its own demise. As the blue stars vanish, the galaxy undergoes a somber transformation of color and character. The vibrant sapphire hues of the spiral arms fade into a pale, sickly yellow as the population of middle-aged stars, similar to our own sun, begins to dominate the light. The nurseries grow quiet. The glowing nebulae, once the sites of frantic birth, dissipate into a thin, useless haze. The galaxy is now in the throes of a terminal decline, a state of being where the rate of death far exceeds the rate of birth. The internal reservoir of cold gas, once a vast and bountiful sea, is reduced to a few scattered puddles, and eventually, even these are exhausted. The galaxy has now become a relic, a fossilized remains of a more creative epoch. It drifts through the void, out of sync with the grand flow of cosmic time, while other, more fortunate systems continue to grow, merge, and evolve. This quenched island remains frozen in its final state. It is a ghost ship sailing through a sea of stars, its crew long since departed, and its engines cold and silent. The history of this galaxy has reached its conclusion, leaving only the slow, radioactive decay of its surviving stars to mark the passage of the eons. This is the loneliness of the dead, a state of existence where no new events can occur, and where the future is merely a long, dark shadow of the past. The transition to permanent stasis is the final stage of strangulation. Once the last of the gas is gone, the galaxy enters the red sequence, joining the ranks of the celestial elite that have finished their work. These systems are often the most massive and imposing in the sky, yet they are also the most hollow. They are monuments to a fertility that has been permanently erased. The stars that remain, the small, cool red dwarfs, will continue to glow for trillions of years, but they are the survivors of a vanished world. They inhabit a system that has been cut off from the cosmic web, a world that has lost its connection to the universal flow of matter and energy. In this state of isolation, the concept of history itself begins to dissolve. For a living galaxy, history is a record of change, of the birth of new solar systems, and the synthesis of new elements. But for a strangled galaxy, there is only the cooling of the embers. The passage of time is measured not by what is created, but by what is lost. The galaxy becomes a closed loop, a system where entropy has claimed the final victory. It stands as a testament to the fact that in a universe of limited resources, the most profound tragedy is not the end of life, but the end of the possibility of life. The diver has run out of air, and the silence that follows is the absolute stillness of a cosmos that has moved on, leaving its most massive children behind in the dark. The local group of galaxies, a small and relatively isolated cluster, of which our own Milky Way is a primary member, is currently moving toward a destiny that has been written in the stars since the beginning of time. Our great neighbor, the Andromeda Galaxy, is currently 2.5 million light-years away, appearing to the naked eye as nothing more than a faint, fuzzy smudge in the constellation of its namesake. But this distance is shrinking. The two giants are falling toward each other at a speed of 400,000 kilometers per hour, drawn together by an inescapable gravitational embrace. This is not a random encounter, but a homecoming of colossal proportions, as the two most massive structures in our local neighborhood prepare for a final, transformative dance. 4 billion years into the future, the night sky above the remnants of our solar system will be unrecognizable. The Andromeda Galaxy will no longer be a distant curiosity. It will have grown to dominate the firmament, its spiral arms stretching across the horizon like glowing ribbons of sapphire and silver. The sheer proximity of another island universe will create a spectacle of light that dwarfs any event in human history. As the two galaxies make their first close pass, the tidal forces will begin to tear at the edges of their disks. Massive streams of stars and gas will be pulled out into the intergalactic void, creating long, luminous bridges that connect the two systems. The sky will be filled with the ghosts of 1 billion suns, all caught in a tidal tug-of-war that spans hundreds of thousands of light-years. This initial encounter will trigger the most spectacular fireworks display the local group has ever seen. As the vast clouds of cold hydrogen gas within the Milky Way and Andromeda collide and compress, they will ignite in a frantic burst of star formation. This is the starburst phase, a brief and glorious epoch where the rate of birth exceeds anything seen in the previous 10 billion years. Thousands of massive blue stars will be born simultaneously, lighting up the merging galaxies with a fierce, ultraviolet radiance. The nebulae will glow with an intensity that turns the night into a permanent, iridescent twilight. From a distance, the two galaxies will appear as a single, chaotic explosion of light, a final celebration of fertility before the long descent into the red sequence. However, this brilliance is the herald of an inevitable end. The very process of creating so many stars at once will rapidly deplete the remaining gas reserves of both galaxies. Furthermore, the chaotic motion of the merger will drive much of the remaining hydrogen toward the central black holes, fueling a brief but powerful quasar phase. The radiation from these central demons will act as a cosmic blowtorch, heating the remaining gas and pushing it out into the newly forming halo. The two distinct spirals, with their elegant rotation and ordered structure, are being systematically dismantled. The orbits of the stars are scrambled by the changing gravitational field, transforming the flat disks into a three-dimensional, swarming cloud. Over the course of the next 2 billion years, the two galaxies will merge completely, settling into a single, bloated, elliptical entity that astronomers have named Milkomeda. The graceful arms of the Milky Way and the majestic disk of Andromeda will be gone, replaced by a featureless, amber-colored sphere of stars. The starburst will have exhausted the fuel, and the feedback from the central black holes will have quenched any remaining potential for birth. Milkomeda will be a red and dead galaxy, a massive tomb containing the combined populations of two formerly vibrant worlds. The night sky will no longer be a tapestry of diverse shapes and colors. It will be a uniform, aging glow, a somber reminder that the era of creation has ended for our local neighborhood. This is the ultimate fate of our home. We are moving toward a future where the Milky Way will lose its identity and its fertility. The merger with Andromeda is the final chapter in our history of becoming a transition to a state of mere being. The stars that survive this collision will find themselves in a galaxy that has finished its work. Milkomeda will drift through the expanding universe as a solitary relic, its connection to the cosmic web long since severed, and its internal engines cold. The great dance of the giants will have concluded, leaving behind only the silence of the red sequence and the slow, inevitable cooling of the past. The vibrant blue of our youth will have been traded for the permanent, stagnant crimson of a universe that is slowly running out of time. Milkomeda sits in the widening void, a solitary island of aging light. The expansion of space, driven by the mysterious pressure of the vacuum, has accelerated to such a degree that every other galaxy cluster has been carried beyond the cosmic horizon. The great filaments of the cosmic web have snapped, and the light from distant neighbors can no longer reach this local sanctuary. The universe has become a lonely place, and Milkomeda is the only thing left in the observable dark. Within this massive elliptical tomb, the stars that were born during the frantic merger with Andromeda have long since vanished. The blue giants and the yellow suns are gone, leaving behind only the most patient and thrifty members of the stellar family, the red dwarfs. These small, humble suns possess only a fraction of the mass of our original star, yet they are the ultimate survivors of the red sequence. Their internal structures are entirely convective, allowing them to circulate their entire supply of hydrogen into their cores with perfect efficiency. Because they burn their fuel with such agonizing slowness, their lifespans stretch across 100 trillion years. For an immense duration, these dim, crimson sparks are the only sources of warmth in a cooling universe. They are the final witnesses to the era of light, huddled together in the center of the galaxy like the last embers of a dying campfire. But even the endurance of the red dwarfs has a limit. Eventually, the last atom of hydrogen in the last star of Milkomeda is fused into helium. The nuclear fires, which have burned across the cosmos since the first few 100 million years after the beginning, finally go out. The stars do not die in violent explosions, they simply shrink. Their outer layers collapse inward until they are supported only by the pressure of electrons packed as tightly as the laws of physics allow. They become white dwarfs, glittering, planet-sized cinders of carbon and oxygen that glow with the residual heat of their former lives. For a time, Milkomeda is a galaxy of diamonds, a shimmering collection of hot corpses drifting through the black. The transition from a white dwarf to a black dwarf is a process that defines the extreme limits of time. It takes 1 quadrillion years for the heat of a white dwarf to bleed away into the absolute zero of the surrounding vacuum. During this epoch, the light of the galaxy fades from a dim amber to a deep, invisible infrared, and finally to nothing at all. The stars become black dwarfs, cold, dark spheres of degenerate matter that no longer emit any radiation. They are the skeletal remains of the galaxy, the iron-hard cinders of a history that has reached its conclusion. In this state, Milkomeda is no longer a collection of suns, but a graveyard of solid spheres, orbiting a central black hole that has grown to a mass of tens of billions of suns. With the extinguishing of the last light, the concept of time itself undergoes a profound transformation. In a living universe, time is measured by change, the birth of stars, the collision of galaxies, the evolution of life. But in the era of the black dwarfs, there are no new events. The universe has entered a state of maximum entropy, where the arrows of time still point forward, but there is nothing left to record their passage. History becomes nothing more than the slow, agonizingly long cooling of the past. The galaxy is a frozen clockwork, a system where the gears have finally seized. This is the death of time, not a sudden stop, but a transition into a state of mere being, where the potential for any future occurrence has been permanently erased. The skeletal remains of Milkomeda will drift through the absolute dark for a duration that exceeds the human capacity for language. Over 100 quintillion years, the orbits of the black dwarfs will decay through the emission of gravitational waves, or they will be scattered into the intergalactic void by rare, chance encounters. The central black hole will eventually consume what remains of the galactic core, growing into a gargantuan shadow that dominates the center of the ruin. The universe is now a vast, empty theatre where the play has ended, the actors have left, and the lights have been turned off. This long decay is the final act of the red sequence. It is the destination toward which every quenched galaxy is moving. The vibrant spirals we see today are merely a fleeting phase of cosmic youth, a brief moment of frantic activity before the inevitable stillness. The transition from the blue cloud to the red sequence is not just a change in color. It is a movement toward this final, dark equilibrium. As the light fails and the stars turn to iron and ice, the universe becomes a monument to its own past, a place where the memory of the fire is all that remains of the brilliance that once was. The story of the galaxies is reaching its final page, and the silence that follows is the absolute, eternal stillness of a cosmos that has finally run out of events. The lone planet on the outskirts of the dying galaxy remains, a silent sentinel in a universe that has finally surrendered its light. The sky above this world, once a theatre of vibrant sapphire and glowing violet, has settled into a profound and heavy darkness. The stagnant crimson that characterized the end of the star-forming era has cooled, and the flickering embers of the last red dwarfs have grown so dim that they are barely distinguishable from the surrounding void. This is the absolute conclusion of the journey, the point where the graveyard of the cosmos has been claimed by a stillness that will never again be broken. From this cold vantage point, the entire history of the universe, from the first scream of light to the final cooling of the red sequence, reveals itself as a single, magnificent arc of energy and decay. We realize, standing at the edge of this infinite night, that we have occupied a privileged moment in the grand narrative of existence. Human history has unfolded within a brief and miraculous window of light, a season of cosmic fertility that exists only for a fleeting interval between the searing chaos of the beginning and the eternal stillness of the end. This era, which we once mistook for a permanent state of being, is actually a rare and precious exception. We live in the golden age of the blue cloud, a time when the universe is sufficiently aged to have forged the heavy elements necessary for life, yet still young enough to possess the cold hydrogen reservoirs needed to ignite new suns. It is a period of exquisite balance, where the forces of creation and the forces of quenching are locked in a struggle that defines the beauty of the night sky. Human existence is the ultimate testament to this brief fertility. We are the conscious children of the stars, the products of the very supernovae and galactic mergers that we have tracked through the deep void. Every atom of carbon in our cells and every trace of iron in our blood was synthesized in the hearts of the giant suns that once populated the spiral arms of living galaxies. We are the universe's way of looking back at itself, the eyes that have emerged from the dark to witness the magnificent drama of its own unfolding. To be alive in this interval is to hold a flickering candle against the rising wind of entropy, to be a part of the light before it is swallowed by the red sequence. The journey through the deadly galaxies, from the internal strangulation of the supermassive black hole to the predatory hunger of the giant ellipticals, serves as a reminder of the fragility of our own home. The Milky Way is not an eternal sanctuary, but a participant in a larger, more dangerous story. The impending collision with Andromeda and the eventual birth of Milkomeda are not merely scientific predictions, but the final chapters of our local history. We are moving toward a state of being where the creative potential of our neighborhood will be permanently erased, and where the night sky will eventually turn that same stagnant crimson we observed at the beginning of our quest. Yet, this realization does not diminish the value of the present. It elevates it to a state of profound sanctity. The fact that the fire burned at all is the greatest triumph of the cosmos. The universe did not have to be a place of beauty, and it did not have to be a place where complexity could emerge and contemplate its own origin. Gravity could have won its battle against expansion too early, or the heat of the beginning could have lasted forever, preventing the first atoms from ever forming. Instead, there was a window. There was a time when the gas was cold, the stars were blue, and the potential for life rippled through the dark like a song. We are the ones who heard that song. We are the witnesses to the flame, the observers who stood on the deck of a lonely planet and mapped the architecture of the heavens before the lights went out. As the last of the energy dissipates and the era of the red sequence claims the final corners of space, the memory of the fire remains the only thing of value. The history of the galaxies is not a tragedy of loss, but a celebration of the fact that for a few billion years the darkness was held at bay. The transition to the red sequence is the natural conclusion of a universe that has spent its currency of creation, a state of rest after an eon of frantic activity. The silence of the graveyard is not a sign of failure, but a sign of completion. The work of the stars is done, and the story of the galaxies has been written in the language of light and gravity. We look up at the night sky now, not with a sense of impending doom, but with a deep and quiet gratitude for the fleeting light of the present. The stars that still burn above us are a gift, a brief inheritance from a universe that is slowly running out of time. Every photon that reaches our eyes is a message from a more fertile era, a reminder that we are part of a grand and beautiful unfolding. The flame was brief, but it was magnificent, and the fact that we were here to see it burn is enough. We stand on our lone planet, watching the last of the embers fade, and we are thankful for the brilliance of the interval. The story of the universe is the story of a fire that eventually went out, but in the heart of that fire, for a brief and glorious moment, we were alive, and we saw the light.